Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Code DTC P0976, which indicates a low circuit condition for Shift Solenoid Valve B in the Honda HR-V models from 2016 to 2022. The DTC typically emerges from issues within the electrical circuit rather than mechanical faults in the transmission system. The solenoid plays a crucial role in shifting gears smoothly within the continuously variable transmission (CVT). Located within this system, the solenoid controls the flow of transmission fluid and assists in gear engagement. Understanding this code is vital for effective troubleshooting and repair to ensure optimal vehicle performance and a seamless driving experience. The primary component affected by DTC P0976 is the Shift Solenoid Valve B. This solenoid is integral to the functioning of the vehicle's continuously variable transmission, CVT. Its role is to regulate the flow of hydraulic fluid that controls the engagement of gears, ultimately affecting the vehicle's acceleration and overall drivability. The valve is situated within the valve body assembly, which houses multiple solenoids and hydraulic pathways. This location plays a vital role as it directly interacts with the transmission fluid, and improper functioning can lead to erratic shifting or poor performance. Identifying and addressing issues related to this solenoid is crucial for restoring normal operation to the transmission system. The potential causes of DTC P0976 primarily revolve around electrical circuit problems, which can lead to malfunctioning solenoid operation. An electrical issue in this context means that there may be disrupted power flow or grounding issues affecting the solenoid's functionality. Another primary suspect is a blown fuse, particularly the number C35 7.5 amp fuse located in the under-dash fuse relay box, which, if compromised, could cut power to the solenoid. Poor connections or loose terminals between Shift Solenoid Valve B and the Powertrain Control Module PCM can also contribute, preventing the solenoid from receiving the correct signals. Identifying these faults is critical, as they can mimic other transmission issues, but are resolvable through appropriate electrical diagnostics. When DTC P0976 is triggered, drivers may experience several noticeable symptoms that indicate a problem with the transmission system. One of the most common symptoms is erratic shifting. The vehicle may fail to shift at appropriate engine speeds or experience delays in gear changes. This can lead to decreased acceleration performance, making the vehicle less responsive to throttle inputs. Additionally, a transmission warning light may illuminate on the dashboard, notifying the driver of transmission-related issues. Addressing these symptoms expediently is essential, as prolonged issues can lead to more significant transmission damage and costly repairs. The first step in troubleshooting DTC P0976 involves verifying the Diagnostic Trouble Code using the Honda Diagnostic System, HDS. To start, switch the vehicle to the on mode and clear the existing DTCs. Once cleared, start the engine and allow it to warm up to its normal operating temperature, indicated by the radiator fan operating twice. Following this, conduct a test drive in D position at approximately 37 miles per hour for at least 10 seconds. After the drive, reconnect the HDS to check if DTC P0976 is pending or confirmed. If it shows a confirmed DTC, it confirms a recurring issue requiring further steps. Whereas if it's intermittent, the system may be functioning correctly but should be checked for loose connections. In the second troubleshooting step, focus on the IG1 missile line to determine if there are any issues affecting the Shift Solenoid Valve B. Begin by turning the vehicle to the off lock mode. utilize the HDS to jump the SCS, System Control Unit line, allowing for accurate measurements. Disconnect the PCM connector A, 51P, and then switch the vehicle back to on mode. Measure the resistance between test points on the connector and body ground. If battery voltage is confirmed, the IG1 missile wire is functioning correctly. If there is no voltage, check for a blown number C35 fuse in the under-dash fuse relay box. If blown, replace the fuse, and if it blows again, a short circuit needs repair. If not, check for an open circuit in the wiring. Next, the third step is to evaluate the functionality of the Shift Solenoid Valve B. Conduct a test to determine if the valve operates correctly. If the test confirms that the solenoid works properly, you can move on to step 4. Conversely, if the solenoid does not function as intended, it signifies that further investigation is required, likely leading to a potential failure area related to the solenoid circuit. Knowing whether the solenoid passes this test is crucial, as it greatly influences the subsequent troubleshooting actions, which could include wire checks or component replacements. In the fourth troubleshooting step, the focus is on verifying the continuity of the wires associated with the Shift Solenoid Valve B. With the vehicle off, once again jump the SCS line using HDS. Then disconnect both the PCM connector B, 51P, and the solenoid wire harness 8P connector located on the engine side. The next critical action is to measure the continuity between specific test points. Ensure that you are measuring while both connectors are disconnected. If continuity is confirmed, that indicates a short to ground exists within the Sol B wire, requiring repair. If continuity is not present, it confirms that the Sol B wire is intact, and you must check if the PCM has the latest software, or consider substituting it with a known good PCM. For the fifth step, the Shift Solenoid Valve B needs a thorough check by removing the valve body assembly. Disconnect the 2P connector associated with the solenoid, followed by measuring the resistance between the designated test points. It's imperative to do this while the vehicle is in the off-lock position, and while both the Shift Solenoid connector and solenoid wire harness connector are disconnected. If the measured resistance falls between 8.9 and 12.2 ohms, the solenoid is deemed acceptable. However, if it fails to meet this resistance, the solenoid valve is faulty and requires replacement, typically involving swapping out the entire valve body assembly if repairs cannot be isolated. Following all the troubleshooting steps, conducting a final repair verification is essential to ensure that the issue surrounding DTC P0976 has been resolved. Begin this verification process by checking for the reappearance of the DTC using the Honda Diagnostic System, HDS. This systematic check is crucial for confirming that the previous faults have been remedied. Following this, take the vehicle for a test drive to observe its performance. Ensure that it operates without errant shifting or warning lights illuminating on the dashboard. Successful completion of these steps indicates that the transmission is functioning as it should, ensuring the reliability and safety of the vehicle moving forward. Preventive maintenance is an important aspect of ensuring your vehicle continues to operate smoothly and avoids issues like DTC P0976. One proactive approach is to regularly check the vehicle's electrical system for loose connections or signs of wear, which can lead to intermittent faults. Additionally, maintaining the integrity of fuses, such as the number C35 7.5A fuse related to solenoid operation, can help prevent overloading or shorts that can trigger DTCs. Conducting periodic inspections of wiring associated with the transmission system can also reveal deteriorating insulation or corrosion that could lead to circuit issues. By investing time in these preventive measures, you can prolong the life of critical components and enhance vehicle reliability. In conclusion, DTC P0976 is a significant diagnostic trouble code indicating a low circuit condition for Shift Solenoid Valve B. Understanding this code and its implications is vital for maintaining the vehicle's performance, especially regarding its transmission system. Thoroughly following the troubleshooting steps allows for accurate diagnosis and effective repair, ensuring that the vehicle operates smoothly without erratic shifting or warning lights. Moreover, addressing electrical issues promptly helps prevent further complications and costs. Lastly, incorporating preventive maintenance practices can enhance the longevity of transmission components and contribute to overall vehicular reliability. Please like and subscribe to the channel. See you next time.